Let us solve problem in electromagnetic induction. Figure shows a straight long wire carrying a current I and rod of length L coplanar with the wire and perpendicular to it. The rod moves with a constant velocity V in a direction parallel to the wire. The distance of the wire from the center of the rod is x. Find the motional EMF induced in the rod. Now assume here. Now see here. In this the rod. In this the wire. In this wire current is passes. Due to this current here, magnetic field will be induced. The magnetic field will be in which direction? Means into the plane. Into the plane. Magnetic field will be induced here. Into the plane will be there. And also you know that this magnetic field, so-called magnetic field induced due to straight wire at a point is equal to formula is mu naught I divided by 2 pi r. So magnetic field is variable magnetic field. Let us take r from the wire, perpendicular distance from the wire we take. Here small part we take, this we take as a dr. This length we take as a dr. Since magnetic field is variable along the r, so that in small part we find EMF. In small part EMF is dE. Small part EMF dE. Here see rod length is x direction is there, velocity y direction is there, magnetic field minus z direction is there. So length, magnetic field and velocity mutually perpendicular to each other is there. So that motional EMF we take as motional EMF we take maximum motional EMF is B into length into V we can take. Here since magnetic field is variable, so that in calculus method we have to calculate in small part of the conductor we are taking, that is dr length we are assuming. Dr length EMF induced is dE. So EMF induced at dr place magnetic field B we assume, that magnetic field B into in dr into V we are taking. Now see here we are under limit we have to substitute in integration, so that this lower limit how much we are taking means this lower limit taken as a x minus L by 2 we are taking, and this length is upper limit, this final length. If you assume A to B, rod length is A to B, and the coordinate of A is x minus L by 2, coordinate of B is x plus L by 2 we will be getting. Now by integrating this equation we can get EMF, induced EMF. Integral D is equal to E, and here B value, this value we are going to substitute. By substituting mu naught I, 2 pi everything constant, so that out of the integral we are taking mu naught I and 2 pi we are taking out of the integral. This V also constant, V also we are taking out of the integral. So inside the integral what is there means dr and divided by r is there. Here lower limit is x minus L by 2, upper limit is x plus L by 2. So now see here this mu naught I, this V divided by 2 pi into this dr by r. Dr by r, what is the integral formula for dr by r means ln r. What is the integral of dr by r means? That is ln r we are getting, ln r. So here this integration is we are taking as a ln r we are taking. This ln r we are going to substitute. R is how much means x minus L by 2, and this x plus L by 2 we are substituting. So by substituting this value mu naught I into V divided by 2 pi, this upper limit minus lower limit we are substituting. Upper limit if we substitute ln x plus L by 2 minus ln x minus L by 2, x minus L by 2. Now see here we know that a logarithm formula log A minus log B. Log A minus log B is log A by B. This is the EMF. By simplifying this one we are getting EMF formula as EMF is equal to mu naught I into V divided by 2 pi into ln of, we are taking this 2 LCM, and also log A minus log B is log A by B. So that we are getting as here ln x 2x plus L divided by 2x minus L. Here actually what we have done in the sense, here 2 is taken LCM and the log A minus log B is log A by log B. The two formula we have taken.